on with the show. Not so very long ago, we lost the ambassador to Libya in a tragic incident in which he was murdered. And this sort of incident produces a particular task and work profile for people, sometimes, in this particular case, mostly people who work for governments, but there are corresponding phenomena that happen in the not-so-governmental world. And the nature of this task is one which is very challenging for search engines. So say that your task was indeed to figure out, as one of the reverberative side effects of this unpleasant incident, what kind of things were going on in some of the more, shall we say, extreme Christian corners of the United States in reaction to the apparent murder, or the certain murder and apparent involvement of Islamic extremists in it in Libya. Now, here's why this is a pain in the neck. I mean, not the task, not the event. The event is a lot worse than a pain in the neck. When you walk up to, let's take the 500-pound gorilla of all search engines, when you walk up to Google and type in some keywords or maybe somebody's name, you have an expectation of moderately relevant results for a lot of topics. What's going on there? Well, any of you who still think that the most important thing that's going on in there is page rank, you need to do some more reading, okay? What allows Google to give you really relevant results when it does, on top of and above PageRank, is the fact that it knows your click history and it knows a lot of other people's click histories. It knows what you are usually interested in, and it knows what a lot of other people who might be somehow profilable, comparable to you are. Now, in the task at hand, we have a very different situation. Something happened, and you have to go figure out about it, and this bears no resemblance to what you've been looking into before. It's a new task, so your history isn't there. And furthermore, maybe not so much on the open web, but in certain kinds of closed document collections, there isn't a click history of other people's interactions with these documents. And so, and in the worst case scenario, which comes up in some cases, there may not even be very many links between the documents. So in these cases, there are certain difficulties in finding your way around, in navigating the possible large number of results of your searches so as to find the information which is actually relevant to the problem at hand. Now, so say you searched for Chris Stevens, who was with the name of our departed ambassador. And you will suddenly discover you have a little problem because there's two of him. There's Chris Stevens, the departed ambassador, and there's also Chris Stevens, who is a particularly, shall we say, vociferous blogger in what some people would call the extremist Christian space. And so when you try to find web pages talking about this, you find to some extent that the signal gets drowned out by the noise. So, like if you look at this first one, here we go, that's his church. And and that's him, not the ambassador. There he is. So that result wasn't very interesting. How about the next result? Well, here we go again. Maybe that could be some other extremist Christian talking about it, but we're not too sure. We'd like to be paying more attention to that one. How about this one? Well, that's definitely about Chris Stevens, though it may not be about our other subject of interest. And then here we go again with a completely irrelevant posting from somebody unrelated to the ambassador who has the same name, who is talking about a completely different subject. So finally, we get this one, which is in fact talking about a Christian charity and its reaction to the assassination of the ambassador in Benghazi. That's really straight spot on to what you're trying to make some sense of. So here's our sort of box score. Of the top five hits, we found two that we really wish we didn't have to spend any time paying attention to, one at the last position, which is exactly what we're looking for, and two which are sort of so-so. That was a lot of work. I mean, and if it didn't look like a lot of work with me pushing this one button over here, imagine if there were thousands and thousands of these hits and you were trying to winnow through them and figure out what is the actual, where is the content you're trying to make some sense of. Can you get anywhere here with text analytics? Well, obviously, the answer is going to be yes, or I wouldn't be standing here, but, So, could we find some way of filtering out the wrong guy? So, how do we do filtering in a Solr or in a Solr search context or any of the related technologies? We use facets. Now, facets first came into all of our existences against structured data. You've got, actually, the most famous database of kind was a bunch of wines. Long before Solr could do a facet, there was a proprietary search engine called Endeca that made its claim to fame out of its ability to do faceted search. And the one and only demo they had for about their first 5 years of corporate existence was the wine demo. I cannot tell you how much fun it was to watch those guys give a demo to a room full of government intelligence officers and be presenting them with everything they ever wanted to know about fine wine. This didn't exactly, there's a marketing lesson in here for any marketing people who happen to be in the room. It didn't exactly speak to them where they were, but I digress. So how would we add facets here? We clearly don't have a database already lying around with the people in it. Well, maybe if somebody's been enthusiastically microformatting their microformat? Is that the term I want? Yes. If someone's been microformatting their brains out there, it might be, but I'll call that cheating, right? There's a vast amount of interesting information there which is completely innocent of microformats. So, we wish we could see some facets. Where might we get some facets? Well, we'd obviously like to see a facet labeled people. Okay, do we know where the people were? Well, any of you who've been to any of these conferences or any conferences like them for the last 5 years have probably seen a colleague of mine talk at great and glorious length about how you can use an NLP technique called named entity extraction to find things like people in full text documents, and that makes you some facets. Isn't that wonderful? Well, just to mix things up, the whole point of that talk is that that's not quite wonderful enough. So what are we going to fill in as the things you can select under the people? And given what I've shown you so far about the existence of these two unrelated people with essentially indistinguishable names, you might begin to guess why it doesn't quite work to just make a facet out of the raw results of a named entity extractor. So first, this is the named entity extraction slide. Here he is. That's a person. That's a person. Okay, we can put them together. We can decide that that's one, that's a single individual in the world. That's a reasonable theory in one news story that if we see the same name string twice, there's only one of him. I'm sure we could find some news article if we liked that talked about the multiple President Bushes that would, cast some doubt on this, but that's not today's problem. But we're still looking to see what do we put in this list, okay? So we could just put the first way each person was named in a document, okay? And here's what we start to get looking at just this document set. We get the Chris Stevens, and a couple of other people. We might click on one of those, and what would we get? Well, it's not going to help us because, in fact, the ambassador exists under both of those names. So even when we do that, we didn't succeed very well at filtering down the content. We have one name and many people the name refers to. I'm sorry, I can never get used to the fact that my screen has a copy of the slides on it, so I'm constantly doing this. So this is, that's one side. So we have this problem called variety. You have one person who has a lot of different names, right? Here he is, and his Wikipedia page will show you that name, and that name, and that name, and particularly that name, K-R-E-E-S, an English spelling of an Arabic pronunciation of the man's first name. How do you like them bananas? All of these are names of him, and if you make each one of these into their own facet, you're not going to be very happy. You're going to be sort of drowning in facets, and you can't get good relevance because you're not grouping them together. So you see, too many. So now, what if we could fix this problem by magic, right? The real researchers in NLP and other areas would call this an oracle, you might say. What if we just imagine the possibility that some automated process or another could figure out how to group the names in the documents according to what person in the real world they refer to? So here comes the grouping. So if we did this for these documents, we'd see that the first one is the minister who happens to have that name. The next three are the ambassador. The next one after that's a minister again, and then the last one, I don't know why we didn't draw an arrow there. Oh no, there he is. Okay. So this doesn't quite solve the problem because we have this problem that the name Chris Stevens with a C refers to both of these people. And so if you make a facet named Chris Stevens, you've got both of them in the facet, and you're still seeing lots of noise that you're not very interested in. This is called the ambiguity problem. So now we have to find the whole solution to the problem, which is to figure out how to decide which Chris Stevenses go over here and which Chris Stevenses go over there. And not only that, to figure out what kind of label would be helpful so that when you look at the list of facets, you can tell who we're talking about. Now, the way we've approached this task, and we're far from the only people who've gone this way, is to focus on linking these names to the real world. If you can not only say, this group of Chris Stevens is the ambassador, and that group of Chris Stevens is the minister, but you can also link that to, and here's the Wikipedia page for one, and here's the Wikipedia page from the other. Now, you can do a little hovering, you can do something, and I think we have some slides to show it. So, these are all him. So, here we have, the sort of magic ball of Wikipedia. And by the way, the magic ball of Wikipedia helps us label that, make one facet, which is labeled with the ambassador, who has a Wikipedia page. So we label it with his actual full name as titled on the front of the Wikipedia page. And then for people who aren't in the Wikipedia page, which includes this minister, we can make one up. We can sort of pretend there was a Wikipedia page. And so now all of a sudden we have two different facets for these two completely different guys. Not only that, we might, be able to label them a little better. Of course, we still have two facets for the, actually, I got a little ahead of myself. So now we've solved the one problem. We've taken them apart, but we haven't solved all the problems of putting them together. So, oh, I'm sorry. It's the cough medicine talking. There actually are two different ministers named Chris Stevens, one with a K and one with a C. There are three different people in here. It gets so confusing trying to keep track of who's on first. That's why we have this problem. So if we fire this up and we click on the guy with the Wikipedia page who is the ambassador, what happens to our result set? Something good happens to our result set. Our result set reduces itself to the two which are arguably possibly relevant and the one which is absolutely certainly relevant, and removes all of the ones which are absolutely clearly beside the point. And if you imagine doing this in a real-world environment where are the usual billions and billions of web pages out there containing, I don't know, somebody's kitty pictures where the cat's name is Chris Stevens, or or a rapper, or or a pop diva, or I don't know, invaders from Mars, you can imagine that there's this thing, as the situation scales, this ability to filter down will get more and more important. Now, it gets even more interesting when we recognize the fact that content exists in the world in lots of different languages. So when you're using a technology like this, all of a sudden you could suddenly start to find the Chinese pages which are also talking about the same guy. Now, I'll talk in a minute without much of a slide net underneath me about what's going on under the table here. I'm really talking about the problem domain primarily in this show. But I feel there is a remark I have to make about the Chinese names because I have to own my own sarcastic remark at the end of Christian's talk earlier today, which is, of course, this is marvelous, but what are the chances that the end user of the system can actually make heads or tails of that blob of Chinese? Maybe not so good. Okay, and what we have to do, therefore, to make that information really usable to a broad class of people is, frankly, a whole other conversation for another time. Now, but nonetheless, they're the same guy. So now, if we go back in the other direction, we can look at the problem of what if your actual research topic of the moment, or your sort of next research topic, was the various Christian ministers instead of the ambassador? Okay, we pick a minister. And you'll notice that we've given you one of the ambassadorial pages. This is really not even slightly a sales pitch because this isn't even a technology for sale yet, but frankly, simply speaking, as a part of the research community building things like this, as opposed to a guy who works for a company who's working on one of these, let me tell you a secret. Nothing like this ever works perfectly, okay? There are going to be errors and trade-offs. Again, those of you who were in Christian's talk this morning heard about trade-offs between precision and recall. The same problem happens here. There's some, the system uses an algorithm, which I'll talk about in a few minutes, for a bit to decide who goes with who, and it's never going to be right all the time. In fact, it has some notion about how confident it is, how much each person belongs in the cluster. So we might imagine giving you the ability to ask how much confidence you want. So if we slide towards fine-grained, well, we only get the one we liked. Of course, in the real world, you might have also lost a few things you were interested in. Them's the breaks. And this is a slide which I'm not really sure it's here, that sort of shows a whole system that incorporates this, but I'll just leave this up here as visual noise while I talk a little bit about what's going on behind the table, and then I'll talk a little bit with some slides about some interesting Solr integration points that came up with this. So what we're trying to do here is group the names in a potentially very large corpus of documents. And in particular, we're trying to group the names in a very large corpus of documents incrementally. I hope I mean, Hadoop is a wonderful thing, but I really don't want to be waiting for a giant batch job to run on a Hadoop cluster in order to be able to provide these results. I want to be able to provide these results in near real time as new documents enter a system. So that means we have to do an incremental algorithm for grouping names together based upon some sort of features. And the features that we're using are document context features. So we look at the document and we look at the names and we look at the words near the names and the other names near the names and a number of other bits of relatively secretive sauce, and we run this into a hierarchy, into an incremental clustering algorithm. And we assign the names to clusters, and so at any time a document shows up, we find all the names in the document, we figure out where they go in the clusters, and that's why we can offer these nice filters down here, or anyone else could either, in a search interface. It's going to make mistakes because, especially when it first begins, it doesn't have very many names. But the way we try to minimize the number of mistakes we make is a real example of doing well by doing good. As I said a while ago, fundamentally, one thing that's really important about a system like this is to be able to relate the names to things in the real world, right? So we'd like, and the real world, heaven forfend, is defined in the current system by Wikipedia. Stop and think about that for a second. So the nice thing about Wikipedia is it gives you, for many, many, many names of things in the more or less real world, and a few fictional ones too, a nice page of text, or more or less nice page of text that talks about it. And so that means the same kind of similarity feature analysis that we're using to group things together works to group things to Wikipedia pages. So if you think about entity resolution as it has taken place classically, classical entity resolution was all about record matching. Oh yes, I have a name and a birthday and a height and a weight and an eye color or an address or something, you know, think of the do not fly list and devices of that kind. And that's really useless if you're trying to make sense of all the names in a giant database of text, because you don't have any of those things. But what you do have is document context, and because we have document context in the Wikipedia, we can do well by doing good. We can do a higher quality job of relating the names to each other by pivoting them through Wikipedia, and we can tell you, okay, what's the Wikipedia page that goes, that goes along with this? So the Wikipedia, of course, is replaceable by any similar large collection of textual documents associated with names. Now, another little sort of teaser about the multilingual problem. So I just showed you a slide there where we said, yippee coyote, we can connect names in English to names in English as spelled in Chinese. Well, so there's a whole other pile of NLP, which the margin is too small to contain today, which addresses the problem of how do you decide when a name you have over here in English is the same as a name you have over here in Chinese. It's particularly amusing in Chinese because people from outside of China who go to China go pick names for themselves in Chinese, which are only moderately phonetically related to their English names. They're often picked to be lucky or auspicious or something. And then there's a phenomenon that happens in reverse. People from a Chinese background who come to this country frequently pick, especially a given name for themselves, that bears absolutely no resemblance to their name in Chinese. Somebody named Lily might decide that she wants to be Cynthia in the United States because, you know, actually Lily's not a hard one to remember, but Chinese people have correctly figured out that us Americans are horrible at dealing with foreign language and that they're more likely to get somewhere talking to us if they assign a name to themselves that our poor little brains can cope with. So this problem only gets worse. To get right into the news, here are just a few of the different ways we observed the name of the deceased Boston bomber being spelled in the news in the first few days after the news story. RNI is the name of our product, which does name similarity comparison, which is a critical part of this overall solution. So you can see it didn't take them long to get him wrong, even in English, not to mention the problem of how he was spelled in Cyrillic. We didn't turn out to have dredged up a Chinese example of this one yet. Now, This brings me to a kind of another point of entry into this that I just wanted to mention in passing because it was an opportunity to learn about some aspects of Solr integration points that actually somebody else gave a whole talk on this conference, but which have not been as widely publicized as some other Solr integration points. So when I started this talk, I showed you what happens when you go to do a web search and you type in someone's name. And the good, bad, or indifferent news was I was able to get some results that contained the actual terms in those that I typed in. And you all know that you can use the Levenshtein distance stuff in Lucene to get some amount of fuzziness, but that's not the best you can do. There are more sophisticated name matching algorithms you can do, which take on board other phenomena like nicknames, which are far, far away in Levenshtein distance. I'm not going to go through the whole detail of this. I'm going to talk a little bit about how this goes into Solr. So I started by emphasizing the question of navigating through facets, but we might have wished that we could type in someone's name that we couldn't spell very well, like one of the bombers, and get a reasonably high recall set of search results. So in order to do that, it's easy enough to define the process, but the question is, how do you fit it into Solr? How do you get to the point where inside of Solr you can set things up so that somebody just types a person's name, for example, into the query box of a Solr deployment, and back come high relevancy results for documents that contain that name in spite of all kinds of spelling variations and nicknames and across languages and scripts too? Well, turns out, as with many other things, Solr has an integration point for this too. So what we did was we pried open what's called the query processing pipeline in Solr. Every time it turns out that you type a query at Solr, it hits a component called the search component, and it in turn runs a whole series of components, one after the other, to do little bits of the query processing chain. I don't know if it was actually invented to support Solr Cloud, but it's extensively used as part of the implementation of Solr Cloud. So what we realized was that we could plug a couple of components into the query processing chain to enable this trickery. So first we have a component which takes the Q string and completely rewrites it. It says, okay, you just said that you want names like Benson Margulies, but in order to do that, I have to create a much more complicated Lucene query under the table in order to generate candidate documents that contain those names, and then we'll filter through them later. So the first component replaces the original query you put in with a much more complicated query. Then further down the pipeline, we have what's called a rescoring component that can paw through all of the hits that came back and then apply a more detailed algorithm to the limited number of results we got in order to tell you what results actually are worth looking at. Now, the interesting thing about this is it's really quite broadly applicable to other problem domains. People build custom query processors, people build custom relevancy components, but at the end of the day, if you really have a yen to just rescore that query, this is the way you can do it. You can stick a component into the query chain that just plays games with the order of the documents. By the way, this is also a way of scaling a computation on the query side across Solr Cloud, because you can put the expensive stuff in the right place in the chain so that it runs on the cloud nodes, presumably on a subset of the results, and then collates the results together for you. It's very helpful. So that's the formal presentation. I am open for questions, and as you see, there are a few soft questions already here. I'm supposed to give a book to the person who does something interesting during the question period, not that I'm particularly interested in being the judge, jury, and executioner of this. Anyway, well, so briefly speaking, let's say you're trying to do searches on names, right? So you might want to take a name in Chinese and expand it into a giant Boolean query on little phonetic components related to those Chinese characters. Similarly for a name in Urdu or Arabic or English or French. And then you might want to turn that into a very complicated query that makes the largest possible use of all of the fancy stuff in the Lucene query system in order to get the best possible initial set of candidate names that might be matches. So that's how the expansion works, is by starting from the name as written, as you see it, and expanding it into these, what we call high recall keys, which are largely phonetically driven, but there is also some orthographic trickery for nicknames. We don't use the Solr synonym system. We build a giant Boolean query that has some of the same effects. So for example, if you put in, oh gosh, what's the Spanish name whose nickname is Chuy? It's, you know, what? Jesus, yes. Okay, so if you put in Jesus, we'll put in a disjunction on Jesus. And so When we first built this, we built it for raw leucine, and we still can operate it on raw leucine, so we don't take advantage of any Solr-specific functionality. We make extensive use of some of the hairier disjunction queries in leucine that, when we first wrote this, are not even available through the normal Solr query parser. So, I'm not doing a great job of repeating questions, but because that one's particularly far back in the room, I'll remember. So, what happens when people arrive who the Wikipedia has never heard of, or who some jerk on the Wikipedia deleted as being insufficiently famous, or whatever? So, what happens is, like the rich sardine of cartoons of my youth, they get a cluster all to themselves on a good day. On a bad day, we accidentally shove them in with somebody else. Now, the way this system will work in a few months, I hope, is that a sort of background process will be running around reconsidering clustering decisions. So even though we might put the Boston bomber in the wrong bucket first, or just put the two brothers in the same bucket first, by the time we've got a couple thousand documents, we could repent of our sins and improve it. It's also important for us to eventually allow for human beings to say, that's wrong. And it's frankly very unusual for people to build systems that do that. It's not that it's easy to do, honestly, but it's a real challenge to us geeks who just want to build an algorithm and stand back to allow for human intervention as opposed to, well, yeah, make some mistakes. Okay, I seem to have run out of you. So, is there anybody who doesn't have a copy of Taming Text who really wants one? All right, well, you actually asked the question, so given the metric I'm supposed to use for handing these out, I think you win the prize. I told you the metric had something to do with asking questions. Thanks a lot, everyone.